Sure. In magnetic effects, what you have studied, beta? Current carrying wire produces current carrying wire produces what? Magnetic field, isn't it? We studied this with the help of what? Biot-Savart's law. Biot-Savart's law. Okay. Now in this chapter, what you are doing to study is right now, by changing the magnetic field, we are producing the electrical current. So now same thing, reverse of this one. By changing magnetic lines of field, magnetic lines of field, we are producing what? Electrical current. Electrical current. In the first case, by changing the current carrying wire produces the magnetic field. Now here, changing magnetic field lines is producing right now for me what? Electrical effect. That process or that phenomena is known as what for me? This phenomenon is known as EMI. Is known as what? EMI. Am I clear with this one? Am I clear? Current carrying wire produces what? Magnetic field. That is by your Biot-Savart's law. Okay, na? Now here in this one, by changing the magnetic lines of the field, we are producing what right now, beta? We are producing here electrical current. This phenomenon is known as what for me? Electromagnetic induction. Am I clear? Am I clear? Sure. First formula on which we need to remember for doing the numericals, that is about your Faraday's law. Faraday's laws. Okay. So now, what a Faraday says that whenever there is a relative motion between the coil and magnet, then an induced EMF or current is being produced in the coil. That is your first law. Okay. So what is the first law? Whenever there is a relative motion, this is a very important term, beta. Whenever there is a relative motion between what? Coil and magnet. Coil and magnet. Then it induced EMF or it induces your current. In where? In the coil. Okay. Or we can even write like this. Whenever there is a change in magnetic flux, whenever there is change in magnetic flux, whenever there is a change in magnetic flux linked with the coil, or we can say with the loop. Okay, there will be induced EMF. There will be induced EMF, electromotive force in the loop. Okay. Now, what is Faraday's second law says that this induced EMF is directly proportional to second point. This induced EMF is directly proportional to rate of change of magnetic flux d phi by dt. Okay. So what is E? E is your induced EMF, electromotive force. What is d phi by dt, beta? D phi by dt is nothing but rate of change of flux. I'll tell you what you mean by flux. Am I clear? Sure. Next slide. Same like electric flux, we are having here magnetic flux. Magnetic flux. Same, just in front of E, we are writing here B. That's it. So flux is directly proportional to magnetic flux is equals to B bar dot A bar. That is equals to BA into your cos theta. Flux is equal to how much? B bar dot A bar. It is BA into your cos theta. It measures what beta? Number of magnetic field lines which are crossing that area. What the flux gives? Flux measures the strength, I can say. Measures the number of magnetic field, number of your magnetic field lines which are crossing that area or given area, we can say. Okay, na? Like say for example, this is a magnet, south pole and north pole. You know that the magnetic lines of the field will start from which pole, beta? North pole, like this. And this will try to take a turn and come back and enter into the south pole. So like this, it will produce the magnetic field like this. Okay, like this. This is arrow mark which are going in the outward direction. Now, if I keep a coil somewhere here, okay, if I keep a coil here right now like this, the number of magnetic lines which are passing through this loop is given by your flux. Am I clear? Magnetic field will start from north pole and terminates at your south pole. Am I clear? Am I clear?
Yes, sir.
Just remember this one better. Condition for current flow. So what are the conditions I can say in which we say that current will be flowing in the conductor. Okay. So for a current to flow in a conductor, beta, for current in the wire, for the current in the wire, there must be following three conditions. Okay, I'm fastly revising it better. You're not going much detail. Okay, what are the three conditions, beta? There should be your potential difference. There should be what for me? Potential difference, or we can say electromotive force, EMF. And it should be a conducting material. The loop what we are taking, it should be a conducting material. If it is like a plastic, it will not conduct. And third one is it should be a closed loop. This is also condition. It should be a closed loop. Am I clear? Am I clear?
Yes, sir.
Now tell me the answer for this one. Like say for example, there is a resistor like this, capital R, and there is an ammeter, this is your A, and there is a potential positive and negative, and this is being connected like this. This is R, there is a potential of your V, and this is your ammeter right now. Now if I say that the wire which we are connecting, this is right now for me a plastic wire. If this is a plastic wire means it is a non-conducting. Then what will be the current in this one, but anyone? What is the current in this one? Current is zero because in plastic there is no flow of a current. If current is zero means EMF is not equal to zero, even though EMF is there, potential is there, but current will be equal to zero. Am I clear? Am I clear?
Yes, sir.
You give me the answer for this one. Like say there is an ammeter here. Okay, and there is a potential, positive, negative. So now tell me what is the EMF for this one? There is a potential. So EMF is not equal to zero. But what will be the current? Current will be how much better? Zero. Because it is not a closed loop now. Isn't it? మనం potential పెట్టాం battery పెట్టాము. There is a flow of a current in this one I. కానీ ఇక్కడ వరకు పోగానే by the time it reaches here, there is no closed circuit. So the current will not flow from that one. Am I clear?
Yes, sir.
So what an area? Now tell me the answer for this one. Like say for example, there is an ammeter, there is a resistor, there is a potential positive and negative, and this is made up of your copper wire. and we are applying the potential. Will the current will flow in this one, beta? This is I1 and this is the
Yes,
resistance
yes,
R. Current will flow, beta?
yes, sir.
Yes,
Yes, sir.
because copper is a conducting wire or non-conducting wire?
Conducting wave.
Conducting wire. As it is a conducting wire, so I can say that EMF is not equal to zero. So current is also not equal to zero. There is a flow of a current in this one. Am I clear?
Yes, sir.
Chalo. One more example. There is a magnet like this. This is a south pole and this is a north pole. There is a copper wire here, right? This is right now for me a copper ring or loop, we can say. So when this bar magnet is made to fall through this one, so what is done? It is producing the magnetic field. This magnetic field lines are passing through this copper wire. So there is change in magnetic flux. Because of change in the magnetic flux, current will be produced. So in this one, EMF is not equal to zero. Current is also not equal to zero. That means there is a potential and there is a current in this one. Am I clear?
Yes, sir.
Now say for example, there is a ring, but this is made up of a wooden ring. This is your wooden ring and there is a bar magnet which has been flowing from here, north to south, that is falling down. So now tell me, there is an EMF because magnetic field is there. Magnetic field is there, so EMF is not equal to zero. But current is how much for me? Zero,
Zero
because
only.
it is an wooden ring, there is no flow of your current. Am I clear? Now, see if the ring is broken
Yes,
like
sir.
this one, and if a bar magnet is flowing south to north, now tell me in this one, because of north and south, the magnetic lines will flow in this one, no doubt. So EMF is not equal to zero, but current will be
Zero.
zero. This is what? Broken copper ring. It is not a closed loop, so there is no flow of your current. Am I clear?
Yes, sir.
Got an idea?
Yes, sir.
Next heading, Lenz's law. Lenz has given me the direction in which the current is being produced. Faraday has given how the current is being coming, and Lenz has been told in which direction the current is being produced. Okay. See here. Whenever, whenever there is change, whenever there is a change in flux, flux means number of magnetic field, flux linked with the coil, linked with the coil, there will be induced EMF. There will be what? Induced EMF or induced current, such that it will oppose it, such that it will oppose the cause by which change in EMF is occurring. Am I clear? Whenever there is a change in flux with the coil, there will be what? An induced EMF or induced current, such that it will oppose the cause by which the change in the EMF is occurring. That means who is producing the current. Or I can even write the definition like this. Whenever, whenever there is change in flux, whenever there is a change in flux linked with the coil, okay, there will be induced EMF. There will be induced EMF or induced current, such that it will oppose the change in flux. It will oppose the change in flux. Now tell me what you understood by this one. Now see, you are listening the lecture. You are listening the lecture is not only sufficient to get a neat seat. What do you need to do? After listening the lecture, you should revise it, you should practice it. That will make you a seat, or that will give you a seat in the medical college. Just attending the lecture, or just listening the lecture, or just taking a book and studying will not give you a neat seat. What do you need to do? After listening the lecture, you need to study. isn't it? Because if I say that only carrying the NCRT books in your hand will give you a medical seat, no. Having NCRT books in your hand is not a reason for getting a medical seat. Having the NCRT book in your hand and studying by using your mind is important to get a medical seat. Am I true? Am I true?
Yes, sir.
Now, what the lens law is
Ardham.
telling, see, whenever there is a change in flux linked with the coil, there will be an induced EMF or induced current such that it will oppose the cause by which the change in the EMF is occurring. That means who is responsible for the flow of this current beta? Magnetic field kada. Who is responsible? The current in the question. Why current is been coming in the coil? Why current is coming in the coil? Because of relative motion between the bar magnet and the coil. If there is no relative motion, if the bar magnet is standing like that, coil is also standing like that, it is producing the magnetic field. Will it produce the current in that one?
No, sir.
No. What is that? Presence of magnetic field, that is presence of magnet and presence of coil is not responsible for producing the current. What is responsible? Being a magnetic field, it should be moving with a certain velocity. There should be a relative motion. There should be a relative motion. Am I clear? If there is no relative motion between copper coil and magnet, then there is no induced EMF and there is no induced current. Am I clear?
Yes, sir.
So what is responsible for the current beta in this one? Presence of magnetic field with the motion. Motion gonna lekapothe, there is no current, there is no EMF at all. Okay.
Okay, sir.
So now what do you mean by this one? The current is being produced because of what? The change in the magnetic field, but not because of the presence of the magnetic field. Okay. Then ultimately, now we'll try to write. And which direction it is better? Opposite to direction of your one. Like say, who is producing the magnetic current here? Change in magnetic field in which direction? If it is in positive, current will be in negative. If the magnetic field is in negative, current will be in positive. Just opposite to that one. Okay, I'll tell you how it is. Just listen it. So now I'll write the next one. Faraday's lens law. After modification, we call this one as of what for me? Faraday's lens law. Faraday's lens law. What is the Faraday's lens law? EMF is directly proportional to the E is directly proportional to d phi by dt. But after the lens law, we write this one as right now for me. E is equals to minus of your d phi by dt. Remove the proportionality constant. We are writing it as E is equals to minus of d phi by dt. Minus n is been given by the lens law. Opposite direction of your Faraday's law. Okay. Am I clear?
Yes, sir.
That means this minus n says that induced EMF will be opposite to what? Change in flux. Okay. Induced negative sign says that induced EMF will oppose change in flux. If change in flux is positive, EMF current will be in negative, like that. Am I clear? Sure. Then answer your point right now. Now listen a little bit carefully, beta. Everyone. If you understand this one, then it will be a little bit easy for doing the numericals. Find direction of induced current. Direction of induced current. Okay. There is a magnetic field like this. This cross represents that magnetic field is into the paper. Cross represents that magnetic field is into the paper. Am I clear? So cross means magnetic field is into the paper. And it is increasing. And it is increasing. Representing with arrow mark. Let's say B is equals to 1 Tesla. Then B is equals to 2 Tesla. Then B is equals to 3 Tesla. Like that, it is going on increasing. Am I clear with you? Am I clear?
Yes, sir.
What you understood by this one? మన దగ్గర magnetic field ఉంది. There is a magnetic field, but it is increasing with respect to time. Am I clear? Am I clear? Now,
Yes,
we are
sir.
keeping a coil in
Yes,
this
sir.
one. We are keeping a coil in this one. This is a coil. So when I keep a coil, I'm keeping the coil in which beta? In which the magnetic field is continuously changing. because it is initially 1, then it is becoming 2, then it is becoming 3, then 4, 5, 6. That means magnetic field is continuously changing. And you know that flux is equals to B bar dot A bar. So flux will be equal to B into area of the coil will be pi into R square. This is the conducting wire of radius R. So this will be the flux. Now I need to calculate the direction of current. Direction of your current part. Now can anyone tell me what will be the direction of your current? Magnetic field is inward. Current will produce in a coil in such a way that it will oppose the increase in the magnetic field. I'm writing SC. Current will produce in the coil in such a way that it opposes the increase in magnetic field. Increase in magnetic field. Am I clear? Am I
Yes, sir.
clear? What do you mean by that one? Current will produce in a coil in such a way that such that it opposes the increase in magnetic field. Like say inside magnetic field is increasing by 1 Tesla. You don't want this magnetic field inward to increase. What you'll do, you'll produce one more magnetic field in outward direction. B is equals to 1 Tesla. Now what is the increase in that one? 0.
0, sir.
Isn't it? If the magnetic field inward is right now 2 Tesla, then current in the outward direction should be 2 Tesla. It should produce the magnetic field outward in the 2 direction, 2 Tesla. So what is the increase in the magnetic field right now? 0.
0, sir.
That means what? Now current, you know that moving current will produce magnetic field better, isn't it?
Yes, sir.
Now see if you remember this one, everyone. Magnetic effects law. I told you that how do you calculate the current in the circular coils? Tell me, what is the direction of the current in this one? If the current is in the anti-clockwise, what is the direction of magnetic field? See the second one.
Clockwise, sir.
Student, ikkada magnetic field direction inward or outward? If the current is in the anti-clockwise, magnetic field is outward.
Outward, sir.
And curl the fingers in the direction of current. The extended thumb is in which direction? Outward direction, na?
Yes, sir.
So magnetic field is in which direction? Outward direction,
Yes, sir.
isn't it? So if magnetic field inward is it is increasing, you should give the magnetic field inward or outward. Like say if I'm saying that you are having 100 rupees, okay, and every time you are increasing your 100 rupees by 1, like 101, 102, 103. I don't want that you need to increase that 101 rupee. What I need to do, I need to take every time 1 rupee from your side. Like say if you are increasing by 1, initially you are having 100, I always want you to have that 100 rupees with you. But you are continuously earning 1 rupee per minute. That means your first amount will become 101. But I don't want that 101, that rupee should become 101. What I'll do, I'll take 1 rupee from you. Okay, now what is amount with you? You earned 1 and you are not increasing it. I have taken that 1. So you are still having 100. You are again earning 1 rupee. Again, I am taking that 1 rupee back. Isn't it? How much it is remaining with you? Constant 100 only, na? That means what
Yes, sir.
I'm not allowing it, I'm not allowing to see that your money is increasing. That means I should make it to decrease so that I need to always allow you to spend at least 1 rupee if you are earning 1 rupee. So you are not able to gain. So your amount will always remain for me constant. Okay, na? So this thing you need to remember here that if the current is in anti-clockwise direction, magnetic field is outward or inward?
Outward, sir.
Outward. Now tell me this one. If the current is in the clockwise,
Inward.
yeah, see in this one. First one, quadrant. Now current is in which direction? Clockwise. What is the magnetic field? Inward or outward?
Inward, sir.
Inward. Got it? Have you remembered this formula? No? Direction? Now using
Yes,
this
sir.
data, you come to this topic now. Now see here. So now what I'm telling here for you, see this one. Magnetic field inside it is increasing. I should not see that magnetic field inward is increasing. So in what direction I should make the current to flow? Anti-clockwise direction. If I am giving anti-clockwise direction current in this one, it is producing the magnetic field outward. So one magnetic field is inward, one magnetic field is outward. So it is not allowing it to increase. Am I clear?
Yes, sir.
That means if it is allowing it to increase, it will not allow it to increase. If it is decreasing, it will not allow even to decrease. Like you say that, sir, you take like this. This is your magnetic field into the paper. Okay, now? And magnetic field is decreasing. Magnetic field is decreasing. Am I clear? I'm keeping a coil in this one. Now current will produce in a coil in such a way that it will not see that your magnetic field should decrease. And if it is increasing, it will not allow it to increase. If it is decreasing, it will not allow it to decrease. And in which direction there should be the flow of current? Clockwise. Because if the current is clockwise, it is producing the magnetic field on its own into the paper. So it is supporting it not to decrease. Am I clear?
Yes, sir.
Got an idea? So what is the direction of a current in this one? I is equals to your induced current. I is equals to induced current in which direction? Clockwise direction. Magnetic field is decreasing. If the magnetic field is increasing, what is the direction of the current? I is equals I is equals to your induced current. I is equals to induced current in which direction? In anti-clockwise direction. Am I clear?
Yes, sir.
Okay. So చెప్పుకుంటే కూడా చాలా ఉంది. Otherwise, it will get a condition. Now let us get the next one. Here, charge flow. Because if there is a current, there will also be the charge, na? Because I is equals to dq by dt, isn't it? So now see here. What is EMF? E is equals to minus of d phi by dt. If there is EMF, I can calculate the current. Current is equals to I is equals to E divided by resistance R from Ohm's law. That is equals to 1 by R. E value is equals to minus of d phi divided by dt. Clear? Clear, beta? The third one. What is the current weight in terms of charge? I is equals to dq divided by dt is equals to minus of 1 by r into d phi divided by dt. Anything is getting cancelled in this one? Dt will get cancelled. So d phi will be dq will be equal to how much better? Charge dq is equals to minus of your d phi divided by your r. Am I clear? Charge is equals to flux divided by resistance. This is your charge flow. This is your flux. Am I clear? Am I clear? So what is the charge
Yes,
formula?
sir.
Charge is equals to d phi by dt. If I remove the minus sign, I can write this one like this also right now for this one. Delta Q is equals to delta phi divided by resistance R. Phi ఉంది కదా initial minus final రాసుకోవచ్చు. Can I write like this? And delta change. Clear?
Yes, sir.
This question, better. I hope everyone knows the basics of differentiation. See here. Flux linked with coil of resistance 2 ohms is given by flux is equals to 5t square minus 4t plus 8. Okay. Find first question. Induced EMF at t is equals to 2 seconds. And second question. Induced current induced current at t is equals to 2 seconds. Come on. Flux is given for me. Resistance of the wire is how much for me? Resistance of the wire is 2 ohm. Flux is equals to 5 into t square minus 4t plus 8. Find induced EMF. What is induced EMF formula beta? E is equals to minus of d phi divided by dt. That is equals to minus of d. Flux will be equal to how much for me? 5 into t square minus 4 into t plus of your 8 divided by your dt. Am I clear? So E is equals to how much for me? Minus differentiation of 5 is out. Differentiation of t square is 2t. So this will become how much?
2T.
10t. Isn't it? Minus 4 is out. Dt by dt is nothing but cancel. 8 is a constant. It will be your 0. So EMF will become how much for me beta? E is equals to minus of your 10t minus of your 4. At what time is asking? At time t is equals to 2 seconds. EMF is equals to minus 10 into 2 minus 4. 10 into 2 is nothing but how much for me? 20. E is equals to minus, this is 20 minus 4. So E is equals to how much for me? Minus 16 volt. Vachinda, am I clear, Afia? I hope you remember this differentiation. Or shall I write it? What is the differentiation formula beta? Y is equals to x power of your n. dy by dx will be equal to n into x n minus 1. I'll tell the first one. See, if y is equals to 5 into t square, I'm taking this one. How I got this relation? So that will be equal to dy divided by, in the place of x, we are differentiating with respect to time. So this is right now. What is the power here right now? In the place of your power, this is 5 is a constant now, so bring it out. So this is the differentiation of your t square divided by dt. Okay, so that is equals to 5. T square is like this one, x power of your n. So in the place of your n, what I'm having? 2. So this is right now for me 2 into your dt divided by dt. Differentiation. Differentiation of this one is how much for me? This one t is nothing but t. This one is right now t to the power of 2 minus 1. So this will be equal to 5 to the 10 into t. 2 minus 1 is nothing but 1. So it is 10t. That is the reason I have written here 10t. What an area?
Yes, sir.
So now tell me what is the current now? If I know the formula. Current is I is equals to E divided by R. E is how much for me? 16. Resistance is given how much for me? 2. So it will be equal to 8 amperes. Got it?
Yes, sir.
Next segment. Motional EMF. Motional EMF. Very important. If there is a certain coil in a magnetic field, beta, whenever a conductor is moving in a magnetic field, the EMF is given by the formula right now for this one. Change in potential will be equal to integral of your V bar cross B bar into DL bar. Okay. If B is constant, if magnetic field is constant, if B is constant, then change in potential of the wire will be equal to BVL into your sine theta. Okay. Why? Because A bar cross B bar is AB into sine theta. Okay. Integral of your DL is always equals to total length of the conductor. Okay, na? Am I clear? If sine theta is maximum, if sine theta is equals to maximum value of sine theta is 1, then change in potential is equals to how much for me? BV into your L or BLV you can write. Or it is change in potential is also written as EMF. E is equals to PL into V. L is nothing but length, capital L or small l, one and the same. V is your velocity with which it is moving. Okay, E is your EMF in the coil. Length is your L is your length of the conductor. P is your magnetic. Clear? Whenever in a magnetic field, if this is a magnetic field, beta, if a conductor is moving in a magnetic field because of the change in the flux in the magnetic field, there is a conductor like this. This is point A and this is a point B. If it is moving with a certain velocity, isn't it? Then EMF induced, where is the flow of a current? This is the length of the conductor, isn't it? So then A and B will act as a what beta? Potential of the wire. And if it is a closed wire like this, then the EMF induced in that one is given by the formula E is equals to BLV. Our general formula will be equal to how much for me? BLV into your sin theta. Motion EMF formula is on the right now for me. BLV into your sin theta. Am I clear? So because of the motion of a conductor, if a conductor is moving in a magnetic field, what is the EMF induced in the coil? What is the formula? BLV sin theta, or maximum value of that one is BL into V. L is your length of the conductor, V is your velocity, P is magnetic field, and E is your induced EMF. Am I clear?
Yes, sir.
Now tell me of A and B, which will be higher end and which will be lower end. This is now very important. Try to learn it along with me. Everyone take your right hand direction of the current. Like say this is the magnetic field which is into the paper. And if I am keeping a conductor in this magnetic field, okay, and I'm keeping a conductor in this. Okay, some uniform conductor. Okay, this is A, this is B, length of the conductor is L, and this is moving with a velocity V. Okay, now take everyone right hand better. Fingers will give me magnetic field. So finger should be in the direction of magnetic field. Thumb should be in the direction of velocity. And palm will give me the higher potential terminal. Okay. Now take your right hand. See, when you slap anyone, how do you keep your right hand? Like that tight, you keep your right hand. Now what you do is fingers in the direction of magnetic field. Now take your magnetic right hand and keep in the direction of magnetic field. Better under, have you kept everyone? In which direction? Inward. Am I clear? Reminder.
Ardhamayindi, sir.
Everyone, fingers in the direction of magnetic field, straight. Then turn your hand in the direction of velocity. Thumb should be pointing in the direction of velocity. Have you kept it?
Yes, sir.
The palm is being projected. Which side? It is either A side or B side.
A.
Everyone, take your right hand and keep your all the four fingers in the direction of magnetic field and turn your right hand in such a way that thumb will be in the direction of your velocity. Then palm is being seen which side better? A side or B side?
A.
A side. That means this will be your higher potential and B will be your lower potential. Got it?
Yes, sir.
That means we can remove this rod and connect by connecting wire. That means this value will become for me higher potential. This value will become lower potential. So we can remove the conducting wire and connect it by your potential of your battery. That is E. And this E will be equal to how much for me? PLV. Am I clear? So we are replacing the rod with a battery. Am I clear? అర్థమైందా? Higher potential will be positive, lower potential will be negative. Okay na?
Okay, sir.
Let us try to practice this one better directions. Now tell me the answers. This one is into the paper. Tell me which will be higher side and which will be lower side. There is a rod which is being kept in this one like this. Okay. This is the terminal A. This is your terminal B. And this is moving in the downward direction with a velocity V, which is making an angle of 90 degrees. Now take your right hand and keep in the direction of your magnetic field. Thumb in the direction of velocity. Where is the palm? Palm is which side?
B.
B. Got it, everyone? So B will be your higher potential. A will be your lower potential. That means I can replace it by your negative terminal, but this will be the terminal of your battery. This is A and this is B. This is E. Got it?
Yes, sir.
Reminder,
అర్థమైంది సార్.
if the magnetic field is into the paper, and if there is a wire which is been moving in this direction right now, and now it is moving in the upward direction with the velocity v. Okay, this one is C and this one is D. Tell me which is on higher end, which will get lower end.
B. Higher.
C is your higher. So this is your higher potential and this is your lower potential. That means I can replace this one with a battery, positive, negative. EMF of this one is C. Got it? అర్థమైందా? No response. This is magnetic field into the paper. Okay. If there is a rod right now for me, this is a rod. These are the terminals. A, B, C, D. I'm taking this one is E. This one is F. And this is moving in this direction with a velocity V, making an angle of 90 degrees with the length of the conductor. Now tell me which terminal is higher and which terminal is lower. Take your right.
E higher, F is lower.
Huh?
E is higher, F is lower.
Very good. E is your higher potential. F is your lower potential. That means this will be negative here. This will be your positive, like this EMF. Got it? Am I clear?
Yes, sir.
How to calculate magnitude? So everyone got an idea how to calculate the direction? Now let us try to see how do we calculate magnitude. If this is the length of the conductor, beta, this is A, this is B, this is the length L. And if the rod is moving with this one with a velocity V, making an angle of your theta, and magnetic field is into the paper, that is nothing but a pure V bar. Then what we'll do, we'll first resolve the V into component beta. One is parallel and another one is perpendicular. V parallel will be equal to V cos theta and V perpendicular will be equal to V into your sin theta. Am I clear? Remember here. Potential difference due to V parallel is zero. What does the meaning? If the rod is moving in the direction of magnetic field, like V component, V parallel, V cos theta is moving in the direction of magnetic field, what is the potential of that one? Change in potential will be equal to how much for me? Zero. Am I clear? So how do you calculate the
Yes, sir.
potential difference? Potential difference is always equals to your BVL into sin theta. That means in vectors you might have been studied this one. All three must be perpendicular to each other. B must be perpendicular to V and V must be perpendicular to your length of the conductor. Everything should be your perpendicular. Everything should be your perpendicular. B, V and L should be perpendicular. Then only there will be a potential difference. What is L beta? L is nothing but for me your displacement vector. It is a displacement vector from initial to your final position. From initial to final position. Am I clear? Am I clear? That means what? Magnetic field should be perpendicular to velocity. Velocity must be perpendicular to the length. If three are perpendicular to each other, then only potential will be there. If any two will be parallel, then potential will be zero. If any two will be parallel. If any two are parallel, then what is the potential difference in this one? There is no EMF. When there is no EMF, then there is no current. Am I clear? Am I clear? So whenever the rod is moving with an angle theta, potential difference is BVL into sine theta. That means magnetic field, velocity, and length all should be perpendicular to each other. And this point is very important here. If any two, that means BRV, VRL, LRB are parallel to each other, that means angle between them is zero, then potential difference will be equal to zero. Am I clear? Okay. Read one more. If rod is rod is in some shape, just join initial point initial point and final point it will give length, it will give effective length, it will give the effective length. What do you understood by this point, beta? If the rod is some irregular shape like S shape, U shape, P shape, semicircle, what do you do it? Just join the initial point and final point. Whatever the point you join it, that will give me the effective length. Am I clear?
Yes, sir.
Let's see, I'll give an example. If this is the magnetic field beta, in which direction is the magnetic field? Into the paper. Magnetic field is into the paper. Now in this one, what I'm doing is, I'm keeping a conductor in the form of your semicircular shape. I'm saying that this is moving with the velocity v in the upward direction. Okay, and radius of this one is equals to r. This is like say starting point A, and this is the ending point, say for example B. Now tell me what you'll do though to take the length of this one. Join initial and final. This one. This blue wala will give me the length. So this length will be equal to how much beta? R plus R. It will be 2R. And the radius, this is R. This is R. Diameter will be equal to 2R. Now tell me which is higher end, which is lower end. Anyone? The rod is right now moving in this direction, upward direction. Take your right hand.
A is higher, B is lower.
Yes, beta?
A is higher, B is lower.
Very good. A is higher, B is at your lower potential. That means I can remove this one, connect it by a connecting wire like this. So this will be your terminal, positive, negative. And EMF of this one is E is equals to B into L into V. What is the length here? 2R. So what is the answer right now for me? BV into your 2R. So answer is equals to 2BV into your R. This will be the answer. What an idea? అర్థమైందా? No response. Afia,
Yeah.
have you understood it? Tanvita, got it?
Yes, sir.
Sure. Take this one more example and give me the answer. A magnetic field is into the paper like this. Okay. I'm keeping a rod of this shape. All sides are A. This one is A. This one is A. This is starting point A. This is ending point B. How do you get the effective length? Anyone? And this total is moving like this with velocity V. Can anyone tell me how do you take the length? What do you do?
A to B.
I told you if rod is of some shape, just join the initial point and final point. Initial point is A, final point is B. Just join this one like this. This LO will become the effective length. Now this is moving with velocity V like this. Now tell me which is higher and which is lower end.
A is higher, B is lower.
A is higher potential, B is your lower potential. That means I can remove this wire and connect like this with a battery. This will be positive, this will be negative, this will be EMF. E is equal to B into, what is the length of this one? A, because sides are same, na beta. This is A means this is also right now for me A only, na. So it is A into your V. This will be the EMF. Am I clear? Am I clear?
Yes, sir.
So next one, rotation of rod, or write the heading as rotational EMF. If a rod is rotating in a magnetic field, okay, this is your magnetic field. And here there is a rod, and this is fixed here, hinge, and total length of the rod is L. It is rotating with an angular velocity omega. This is a point A, and this is your point of your B. Okay. Now, this is the distance of XA, and this is the distance of your XB. So, whenever a rod is rotating in a magnetic field, this is XB. Just a minute. Did anyone remember the formula? Due to the rotational EMF, potential difference is given by the formula delta V is equals to, with me my charging is over beta, delta V is equals to half into B into omega into XB square minus of your XA square. This is the formula. Delta V is equals to half into B into omega into XB square minus of your XA square. Am I clear? Whenever a rod is been rotating, due to the rotation, the EMF is given by the formula E is equals to half B omega into XB square minus of your XA square, because I have taken the points in the diagram A and B. So XB minus XA will give me the potential. Am I clear? Am I clear?
Yes,
Yes, sir.
Now give me the answer for this one. Good example, just stop out and wait because charging is over. Just tell me the answer for this. If there is a rod like this, now the axis is at the center like this. It is rotating with angular velocity omega. This is A, this is B, and magnetic field is in this direction. Okay, and this one is length L, and this one is length L. Now tell me what is XA in this one, beta? XA is equal to how much, beta? L now from the axis. What is XB, beta? XB from the axis is how much for me? L. So what will be the potential difference? Delta V is equals to half into B into, this is your omega into L square minus L square. So potential difference will be equal to 0. Am I clear? Achinda. What is,
yes, sir.
tell me the answer for this one. If there is a rod like this, okay, and this is the point where it is been hinged, origin. This is say for example P, this one is say for example Q. That means it is rotating about this one with angular velocity omega. Clear? This one is 2L. This one is right now for me 2L. This one is 2L. This one is 4L. Q2O is 2L. O2P is 4L beta. Am I clear? That means X of your P is how much for me? X of your P is how much? Anyone? XP is how much beta? P of rotation is how much?
4L,
And XQ is how much for me? 2L.
2L.
So potential difference will be equal to how much better? Potential difference is half B into omega. This one is your XP square minus of your XQ square. Higher value minus lower value. So it is half B into omega. XP is how much for me? 4L whole square minus 4
Omega.
square. So this will be equal to how much for me? Half B omega into 16 L square minus 4 into L square. 16 minus 4 is how much?
12.
12. So it is your half into B into omega into this one is 12 into L square. 2 ones are 2 sixes are. So this answer will be 6B omega into L square will be the potential difference. Achinda, if you are getting
Yes, sir.
the question, this is the way how do we try to do it out. Am I clear? Done? Archita,
Yes, sir.
clear? Tanvita,
Clear, sir.
okay. సో నేను నోట్స్ పంపిస్తాను ప్లీజ్ గో త్రూ దిస్ వన్ నేను మీకు ఎంతైతే నెక్టార్ అవసరం ఉందో అంతే చెప్తున్నాను సో ఈఎంఐ మీరు ఒకవేళ చదవకపోతే ఇప్పటి వరకు టిల్ నో ఇఫ్ యూ హావ్ నాట్ స్టడీడ్ ఈఎంఐ just whatever I told you today you just go through that one. The recording is also there. I'll upload it on the YouTube. If you are getting any doubt you can just go through there and see the what section you have been missing. And just you need to just two formulas we are derived today. One is for you how to calculate the EMF when there is a flux. E is equals to d phi by dt. Another one is we calculated motional EMF if a rod is rotating. Sorry, if a rod is just moving translatory, then EMF is VLV. If the rod is rotating, then EMF is given by the formula E is equals to your half B omega into XB square minus of your XA square. Am I clear? Okay, no?
Okay, sir.
Sure. ఇంతవరకు చదవండి ఈ రోజు more than enough. In the tomorrow session of a class, we'll try to start with your self-inductance and mutual inductance part of relation and transformer application. Then that will be the ending of this chapter. Okay. Still there is a lot depth better, but that depth is not required at this time. Whatever I've been taught you today, you just go through them. If there are any problems based in such manner, like say rotational EMF, how simple I made it you. If you get a question when a rod is rotating in a magnetic field, you just need to remember this formula. Delta V is equals half B omega into XB square minus XA square. Previous knowledge is not at all required. Just remember this one and try to practice these two problems how I have done. Now take your PYQ booklet and see some questions on rotational EMF and the E is equal to BLV. You will get an idea how the problems have been framed. And you know how to calculate the directions also. I told you how to calculate the direction by your in the direction like that. If the magnetic field is increasing, the current will be in the clockwise, inward. Okay. The same thing is with the outward also. If the magnetic field outward dot is the same way you need to take. Just keep in mind that whenever you're calculating the direction, it should be always in the direction of opposite. If it is increasing the magnetic field, it will not allow it to increase. If it is decreasing the magnetic field, it will not allow it to decrease. The magnetic field may be inward or it may be your outward. That depends upon the situation of your problem. Am I clear?
Yes, sir.
Okay, so just take some 5-10 minutes time or half an hour time and just go through this formula booklet, what I have been told you, and try to do some PYQs. Just do the PYQs on this topic. E is equals to BLV, E is equals to half B omega into your XB square minus XA square, and EMF is equals to minus of d phi by dt, and charge delta Q is equals to delta phi divided by resistance R, and current I is equals to E divided by R. Clear? There will be some 10-12 questions in PYQ. Just go open that one. Don't do the self-inductance and mutual inductance and transformer problems. Just in half an hour, you try to take the problems and try to complete your PYQs. And see how the question was in 2024, 23, 22, 21. Were there any question based on this topic, what we are studied right now? No. There will be maybe a question on transformer, maybe self-inductance or mutual inductance. That we'll try to do it in the tomorrow session. Am I clear?
Yes, sir.
And now at 10 o'clock, you're writing the grand test of, modern physics exam.
Yes, sir.
I'll send you the paper exactly at 10 o'clock in your WhatsApp group. Keep that 10 to 1, 10 to 11, you try to do how many questions you can do, you try to do that one because there is a logic gates problems. There are some, what do you call the zero diode questions or maybe photoelectric effect questions. At least 10 questions, 12 questions if you are able to do. Just see that whether you are able to do in that examination hall or not. Then afterwards, you'll try to discuss the paper. Okay, but tomorrow we'll try to keep the full stop for the EMI. Okay.
Okay, sir.
And morning 5 o'clock, are you okay better for the grand test papers solving?
Okay, sir.
In the morning 5 o'clock under until from today on tomorrow onwards, 15th is there now. We'll start doing with the first grand test paper. I'll just share you the grand test paper in the morning, same ID and same password. We'll try to do daily one grand test paper, so it will be a revision of all the questions once. Just read the question, write the data. I'll go on, tell you the formulas and see the reading the problems. You try right because you need to take a screenshot of the paper better. I'm not going to send you the paper. I'm not going to send you the solution. On your paper, on your mobiles, you need to take the screenshot of that questions and I'll go on help you out with the formula and just the data. If there is any depth question, I'll try to do it out. If it is directly formula based, I'll just give the hint and write the formula, take a screenshot and try to do it again once again on. If I send you the paper, you will be not doing. That is the reason I just need you to be attentive in the class from 5 to 6. In 1 hour, we will try to see that. We'll try to read the complete question paper and try to at least attend 20 or 25 questions in that paper. Okay, na? So like that, we'll be practicing daily one paper. So we'll be doing almost like 15 to 20 papers daily in the morning session. Am I clear?
Yes, sir.
Sure. Take care, beta. Bye. So tomorrow there will be paper the grant is starting from morning 5 o'clock, 5 to 6. I'll try to directly take daily one extra class apart from these 2 lectures for your grant test papers. Okay, na?
Okay, sir.
So, bye.